Good afternoon, students. Today we can discuss a new topic, that is manganese reagents oxidation. We know that manganese oxidants, for example, potassium permanganate is a derivative of heptavalent manganese, which is also a very powerful oxidizing agent, and it reacts, or the reactivity of this manganese oxidants depends on whether it is used in acid medium, neutral medium, basic medium, like that. That is, in acid medium, acid solution, this manganese is reduced to manganese 2. That is, manganese 7 will be converted to manganese 2 with a net transfer of 5 electron. And we can say that in the neutral or basic medium, this manganese dioxide is usually formed. In neutral or basic medium and neutral medium, it will be giving manganese dioxide, and that is only 3 electron exchange will take place. That is, manganese 7 will be converted to manganese 4. Usually used reagent is potassium permanganate, and this manganese potassium permanganate is a strong, we all know that it is a very strong oxidizing agent. And this potassium permanganate can be used for the oxidation of alcohols. Alcohols are usually oxidized using potassium permanganate, and the reaction proceeds to form carboxylic acid. Alkyl side chains are also getting oxidized to carboxylic acid, and this method can be used generally to it is applied to methyl group, or however long side chains also can be cleaved using this manganese 7 oxidants. Then another example, we can say that the tertiary alkyl groups usually are not oxidized and are usually accompanied by ring cleavage. And we can say the primary alcohols will be getting oxidized to aldehyde first, and it will be converted to carboxylic acid. For the mechanism, it is same, or it will proceed as the same as in the chromium. That is, we have studied, that is chromate ester formation, intermediate chromate ester formation. Like that, you can also see the chromium, how this is, chromium is undergoing, or the mechanism is explained. In a similar way, it will be forming a manganate ester. For this mechanism, you can see a link I have given here, or you can click over here. That is, you can click on this underlined heading on KMNO4, and you can go open hyperlink. When you right click, you can see an open hyperlink, and just click open hyperlink, you can go to directly to the YouTube. That link is this, and you can see the mechanism very clearly. It is same as the chromium oxidant mechanism. And in the case of KMNO4, it is also used for the oxidation of alkenes to diols. That is the mechanism. Here we can simply explain, that is, it is by a cyclic intermediate formation. That is, the KMNO4 will be or it will be converting to K plus and MnO4 minus, that we all know. That is K plus and MnO4 minus. That is, this will be carrying a negative charge, and here the 5 electrons are there. It will be forming a cyclic intermediate like this. This molecule is highly unstable, and this highly unstable molecule, it cannot exist like this. Therefore, that is 2, 3, 4, 5. That is, the double bond is here, and it will be forming link with this pi electron will be forming a weak bond here, and this O minus will be shifted towards this side, and the manganese will be, the electron density is increased, and it will be shifted towards oxygen, and this oxygen will be carrying minus charge here, that we can see, and the molecule will be forming like this. And to this position, then next taking place, in the mechanism, the next process is hydrolysis. That is, this O minus will abstract H plus ion, and this OH will be getting attached here. That is, OH will be getting attached here, that you can see here, and the remaining OH minus is here. This OH minus is in the medium, and this will interact with this Mn, that is the transition metal, and that is this, when MnOH is getting, or this will interact, or this will be abstracted by this since, and here the electron will be, the oxygen is electronegative, that is the reason, that is oxygen is electronegative, here it will be getting minus charge, then it will be developing a positive charge, and this towards this positive charge the OH minus will be getting attached, and that you can see here, and this will be forming O minus, that is this process again repeats and it will be forming a diol. The molecule will be forming a diol. Oxidation of alkenes to diol take place through a cyclic intermediate mechanism, that is this cyclic intermediate is unstable, that is the main thing, and this will be forming, or syn hydroxylation will take place in this molecule. Syn hydroxylation, in this two molecules are involved, and the process continues like this, and it will be forming, diols will be formed. That is the mechanism. You can easily explain the mechanism, or if any question it is asked, instead of this cyclic compound, any molecule, it will be forming a intermediate cyclic ester like this. Then next, protected hydroxyaldehydes are also oxidized to corresponding carboxylic acid with KMnO4, and you along with for this mixture of tertiary butanol and sodium dihydrogen phosphate is usually used. We can see that this aldehydes, these are the protected group, and this hydroxyaldehydes protected group is here with the silicon, and dimethylsilyl group is there, tertiary dimethylsilyl group is here, and this CHO group is getting oxidized as in the same case, that is it will be oxidized to carboxylic acid. For this also we can use KMnO4, then tertiary butyl alcohol, and 5% sodium dihydrogen phosphate. Another one is Bayer's reagent that you have all studied in your degree classes for your practical organic practicals. That is Bayer's reagent is dilute solution of KMnO4 is called as Bayer's reagent. This is also used for the dilute solution of KMnO4, that is the earlier mechanism can also be the same mechanism, that is in the earlier mechanism it is explained in detail, that is this alkenes are converted to diols, that is we usually this as a test to for unsaturation we usually use this test, that is if you are adding dilute 1 drop KMnO4 to this, it will undergo decolorization and this will be due to the formation of diol, that is it is believed to proceed by a cyclic permanganate ester formation. Here you can see that is in the earlier slide we have explained in detail, and for exam point of view, you have to note if you are seeing KMnO4 and alkene, you have to note that it is it is very stereoselective reaction. Syn addition will only take place. The two hydroxyl group will be added across a double bond. Then this one I have given as the assignment, and the students have written the assignment and returned me back, and the answer is also given here, and this is the answer. It will undergo first a primary alcohol will be oxidized to aldehyde by forming a like chromate ester. Here manganate ester is formed and it will be forming carboxylic acid, which subsequently cyclizes, or it will eliminate one molecule of water to give a lactone. Then next reagent is manganese dioxide. Manganese dioxide, as all of you know, that is manganese dioxide is also a selective oxidizing agent for organic synthesis, and this structure and the activity of the reagent varies according to the method of preparation, and we know that it is commercially available and can be prepared by the reaction using potassium permanganate with manganese sulfate, or manganese tetrahydrate with potassium permanganate in aqueous solution. We will get the MnO2 as one of the product. It is also used for the conversion of oxidation of alcohols. MnO2 is used for oxidizing allylic benzylic alcohols to carbonyl compounds. If a benzyl alcohol is taken and in the presence of excess MnO2 and CCl4, benzaldehyde will be the product. If you are taking crotyl alcohol, it will be giving crotonol aldehyde. Like that, the advantage of the reagent is that the reaction will take place under mild or neutral condition. That is, olefinic or acetylenic bonds remain unaffected. That is the peculiarity. That is, in this example you can see there is a double bond here, but here is the OH. In the presence of MnO2, the double bond will remain here and it will be remaining unaffected, and this will be converted to CHO. Then MnO2, it is used to prepare we can see the applications. If you are explaining, we can say that it is used in the preparation of retinol you have heard, that is vitamin A retinol in the presence of MnO2, manganese dioxide you are using it as a laboratory reagent, and it is used for converting secondary alcohols to corresponding ketones. Vitamin A will be converted to retinol, or we can say that in certain condition or ordinary condition it is not affected by the not oxidized. Saturated alcohols are not oxidized by MnO2. That means if you are taking in the acetone medium, the selective oxidation for allylic or benzylic hydroxyl group will only take place. And this is one of the proposed mechanism for the oxidation of alcohols. That is, in the case of alcohols, the conversion of alcohols to aldehyde. Here you can see C6H5CH2OH is converted to C6H5CHO. And in this molecule, in this mechanism, we can say that it is formed or it is adopting a radical intermediate. Alcohol is absorbed on manganese dioxide, and there is the formation of a coordination. Complex. That is, this is the structure of MnO2, and when this is added, it will be forming, this will be getting absorbed on manganese dioxide, and it will be forming a coordination complex. That is coordination complex 1. And electron transfer from the alcohol to manganese. Electron transfer from alcohol to manganese will take place, and it will generate a radical. This radical will be generated. That is, this is the radical formed, and further it is reduced to Mn3 or further Mn4 is reduced to. In this process, we can say that further process, that is Mn4 is reduced to Mn3, and this Mn3 is converted to Mn2. Mn3 is converted to Mn4 is reduced to Mn3, and we can say the second electron transfer will generate the carbonyl product along with or this is only a proposed mechanism, that is MnOH twice will be formed, and finally this MnOH twice will remove a one molecule of water. H2O will be removed and it will be forming MnO. That is, MnO will be formed, and the formation of carbonyl compound along with the MnO. MnO means manganese oxide. Manganese oxide as well as C6H5CHO will be formed. This is one of the proposed mechanism. This was suggested by Goldman and Henbust, and the oxidation of allylic alcohols with MnO2 can be stopped at the aldehyde stage, and further oxidation to carboxylic acid will not take place in this case if you are using MnO2. If you are using KMnO4, this will proceed to form a acid. In the presence of HCN, we can say that it will be converted to a cyanohydrin, and later it will be forming or further reaction, further oxidation. It will be leads to the formation of a sometimes it will be forming a carboxylic ester or like that. And another important feature of this reaction is that it will be it proceeds in high yield without any isomerization. It will not undergo, and a higher temperature, or usually if you are using sufficient reagent, pure solvents, or if you are using we can oxidize even saturated primary and secondary alcohols, and this is one of the application, that is transformation, that is in this conversion it will proceed without cis-trans isomerization. That is one advantage, and it is the reagent is sensitive to steric interactions also. it can be used for the oxidation of amines. That is another application, that is it can be used for the oxidation of amines by MnO2, and oxidation of amines to various products can be carried out, and the formation of amide or a diazo compound, like that we can explain. And another advantage is that MnO2 can be used to convert, or the oxidation of hydrazo compounds, oxidation of sulfur compounds, etc. can be carried out. And you can study any of the two examples as application. Acetylenic alcohols and benzylic alcohols are also oxidized under similar condition. Here we can say that the double bond here remain unaffected in the presence of MnO2. Only the CH2OH will be getting affected. Oxidative cleavage of MnO2 1,2-diols also can be explained. That is, these all are the applications. Primary nitro compounds are oxidized to alcohols by MnO2. Here, that is earlier I have explained to you, that is there is the formation of cyanohydrin, and this cyanohydrin molecule will react with, or this is the mechanism or the proposed mechanism, that is in this here we can say that this nitro compound on reaction with water, it will be forming a cyanohydrin, and these cyanohydrins will be reacting with the manganate ion or MnO4 minus, and it will be forming a cyclic, or it will be forming a cyclic state, because this pi electron will interact with the O minus, that is the oxygen here, that is this nitrogen, and the here we can say that this O minus electron rich compound, and this will be electron withdrawing tendency and rich in electrons, and it will be interacting with the manganese ion because it has D5, or it will be not D5, it is a transition element, and it will interact with the manganese, and it have orbitals, vacant orbitals are there, and this, when it is having an interaction with the manganese, this will be shifted towards this side, and this will be shifted towards this side, and we can say that in this case this will be, once the electron is shifted, that means NO2, N double bond O will be formed here, and NO2 will be removed as NO2 minus. NO2 minus will be removed, and here it will be forming Mn double bond O MnO3 minus, and this bond, earlier I have told you that this bond will be shifted towards this side, and that means this will be released. This will be released as MnO3 minus, HMnO3 or MnO3 minus, NO2 will be released, or NO2 minus will be formed. This will be double bond, and this will be minus charge, and NO2 minus, MnO3 minus, and this bond will be shifted towards this side. That means this is broken. That means this is a highly unstable molecule, and that means this will be forming RCHO. And the rest of the these are the two manganese reagents, important manganese reagents, that is KMnO4 and MnO2. Along with that, sometimes Bayer's reagent also will be asked for the exam. So you just go through this, and we can discuss it in the next class. We can discuss it in the next class. Thank you. Let me stop here.